Hello and welcome to the fourth part of the series Programming from the Perspective of a High Schooler. So today we're going to discuss about operators, and I know I am sorry this should have been the third part of the series instead of user input. But anyways, I will upload it on the same day, so I guess that's fine. I'll just leave a note in the description, okay? So basically we're going to discuss about operators. So basically, I'm going to discuss about operators based on the order of precedence that it gets operated on. So, so let's start. So, the first operator is the scope resolution operator, which we have already used before. So, std cout h semicolon. So as you can see, this double colon here is called the scope resolution operator, which basically tells us where this cout function can be found. Okay, so basically, that's that. I'm not going to explain the scope resolution operator. I just told you that we've used it before and that it's on the top of the order of precedence. Why? Why not? Because uh, the other uses for this, I mean, the scope resolution operator has a lots of uses, okay? But we won't probably use it for now, so I guess we can leave it at that. Well, I guess one example wouldn't hurt. So for example, we have int num equals 10, then we have cout num, then let's say we also have int num equals 20, semicolon, and yeah, the scope resolution operator. Okay, that's one colon extra. Compile and run. What would be the output? So the output is 20. So basically, the scope resolution operator can also be used to access variables that are global, that aren't inside the local int main function. So basically, what I'm saying is that this num variable here is a local variable that is specific to this int main function. Now, by using the scope resolution operator, the scope resolution operator being a pre-variable, being a prefix, no? So when we use this scope resolution operator, we were able to tell the compiler that the value of the variable, or the variable itself that we want, is the global variable found found outside the int main function. Okay, so I know it's a bit confusing, but I just gave an example, so yeah, I'll discuss it another day. But today is not the day because we have a lot of operators to discuss. So the next set of operators are the increment and decrement operators. So basically, the increment and decrement operators are simply increments and decrements. So for example, let's say we have a variable called num, declaration, data type integer, variable name is num, then the assignment operator equals sign, then let's just say the value is 5. Now what we're going to do is basically just a cout function and then the insertion operator. We're going to keep it simple, so I'm not going to put any strings at all, just the value itself. I mean, you can see the source code right now, so I guess it would be fine. So int num equals 5, so the value of the variable num is 5, no? So if we write num, then the output would be 5. Okay? So the increment operator is basically a plus plus sign. Actually, okay. So, I'm going to discuss it after we run the code, okay? Compile and run. The value should be 6, right? No. Because 5 plus 1 equals 6, and the increment operator basically increments the value of the variable by 1. Okay? So, that's simple. Very straightforward. But, what if we put the increment operator after the num, after the variable name? The output would be 5, supposedly. Alright, the value is 5. That's because the difference between the prefix increment operator and the postfix increment operator is that if the increment operator is a prefix, basically the operation is performed and the operation is performed and the result of the operation will be returned. Okay? Will be returned immediately. But if the increment operator is a postfix, then the operation would be performed, but the original value of the variable would be returned. Okay? Medyo magulo ba? Pero, yun. So, basically, if we do this, basically, the output would be 5. But the value of the num now is 6. Okay? So basically, the operation was still performed, but the return value is still the original value. But if, for example, we do this, the the increment operator plus plus is a prefix, then basically, sorry, I forgot to close the previous. Wait, let me just run it again because I think I forgot to close the previous console. Kaya hindi yata nakita ito. So, basically, again, I'll just repeat. Sorry, wait. No. Okay, tama. So, 6 ba yung nakakita? Parang 5 kasi. So, basically, if the plus plus sign is placed before the variable, then the return value will be the result of the operation performed, which is num plus 1 or the num incremented by 1. Okay, so basically that's that. But okay, let me close this. If this plus plus sign is placed after num and then we execute, compile and run, then the output would be 5. Okay, but still the value of num now is 6, but the return value is 5. Okay, so, medyo magulo yata yung sinabi ko, pero ganun kasi yun. Okay? Now, the next operator is the decrement operator. It's basically just the opposite of the increment operator. So, compile and run. The output would be 4 because 5 minus 1 is 4. 5 decremented by 1 is 4. Okay? So, that's that. That's the increment and decrement operators. They're actually very straightforward, and I only made it more complicated by explaining the difference between the prefix and the postfix use of the increment operator and the decrement operator, so that if you write the code in your own, then you wouldn't have to suffer errors like this, like me. Okay. Okay, so the next operator, so basically we're just going to skip the function call operator, the subscript operators, the member access operators, because we can't use them right now at this moment because we haven't discussed functions yet. We haven't discussed arrays, we haven't discussed classes. Okay, so let's just skip that for a moment. Now let's say we have a character, then let's just name it character A equals. So of course, reminder, if we make characters, they have to be inside, what do you call this? Single quotation marks. Okay. Let's just say we have character 1. character 1. Now, what do we want? We want to see out insertion operator, and then the the bitwise not of 1. What is the bitwise not of 1? So the next operator is the not operator, specifically the bitwise not operator. Now, the returned value of this should be the bitwise not of 1, or the bitwise complement of 1. So execute, compile, and run. So the value is, oh no. What did I do wrong again? No, wait. Let me change this to 5. Execute, compile, and run. Negative 54. Negative 54. Wait. Okay. Seems like my compiler has something wrong, but I will just explain the concept of the bitwise not. So basically, if the symbol for the bitwise not operator, which is a unary operator. Unary operator means it's an operator that performs only on one operand. So the what do you call this again? The bitwise not operator is a prefix unary operator. Basically, it should be written before the variable itself. Okay. So what we're going to do now is basically var name equals, okay, ito na. So for example, if let's say our character is 1, character char a equals 1, okay? Now, what is the storage size of characters? So the storage size of characters is 1 bit, right? Wait, let me recheck. Let me try checking it. Char a size, wait, no. See out size of char a. No, sorry. Char a. Execute, compile, and run. Sorry. Size of, execute, compile, and run. Okay, so yeah, right. The size of characters is 1 byte. So we have char a, meaning when we say size, so the size of characters is 1 byte, right? 1 byte, meaning 8 bits. So basically, 8 bits, meaning the maximum value that can be formed is basically 111, okay, 111, basically 81. So this is equivalent to 2 raised to 8. Am I correct? I think I'm correct. Wait. Let me recheck. Let me just make sure that I'm correct. So 111 in decimal. Wait. 111. Wait. Binary to decimal. Yeah, enter binary number 1111111. Convert. So, apparently okay, 2 raised to 8 minus 1. Because 2 raised to 8 would be 1 and 1, basically 1 and then 8 zeros, okay. 2 raised to 8 minus 1, which is 255. Also equivalent to, FF, if you would. So basically, just additional information. So, equals 255. So basically, now let's proceed to what do you call this? The bitwise not operator. So, nawala na tayo dun. So basically, car A, its binary equivalent is 000 001, okay? So basically, that's that. Then, if we perform, where is it? Okay, that, and then A equals, so let's say A equals this. A equals 001. Then then the complement of A, or the bitwise not operator performing on A would return 11111110, which is what? Which is, I think it's 254. Is it 254? Sorry, wait. Okay, right, it's 254. Decimal right. So, okay, let's try again. Unsigned char A equals 1. And then, C out, and then the bitwise not operator, A. Execute, I don't know, not run, rather compile and run. Compile and run. Wait, no, sign pala. What? Why? Okay, I give up. But still, that is the concept behind that. Behind the bitwise not operator, I don't know why it's not working for me. I already no, didn't work for me before. I already tried it. I had to repeat this video because I thought I did something wrong, but unfortunately, I don't think I did something wrong. Okay. Now let's proceed to the next operator, which is the logical not operator. The logical not operator, basically, it returns the opposite of what actually is true, okay? What actually is true. So, for example, um, we have int A equals 2, int B equals 5, okay? So, if we just say, okay, let's also make C. So, basically, if we try C equals, uh, A is less than B, or A is greater than B. A is greater than B. Is A greater than B? Is 2 greater than 5? No, that is false. Meaning, by binary terms, the output should be 0. So, because that is not true. So, C out C. Execute, compile and run, and then compile and run. There, the output is 0. But if we use the not operator on this one, the logical not operator, then what will be the output? The output is 1, okay? It's that simple. It's very straightforward. The logical not operator is very straightforward compared to the bitwise one. But, there we have it. So, okay. Nakikita ba? Okay, nakikita naman yata. Okay. Now, let's proceed to the next operator. What is the next operator? The next operator is the unary prefix operator. Rather, the unary positive operator and the unary negative operator. So it sounds complicated, but it's not. It's actually very simple. It's literally For example, if you have an integer -2, then you have to see out A. What will be the output? Obviously -2 because that's the value of the variable. That's the value of the variable A. Did we use any operators besides this assignment operator, this insertion operator? Well, of course we did. It's the unary negative operator. Basically, we negated the sign of 2, which is assumed to be positive at first. So, it's literally just that. If we do positive here, we do positive, execute, compile, and run, then the output would be 2. Apparently, we don't need to put positive signs. We don't need to put the unary positive operator anymore. Not normally, that is, because the numbers are assumed to be positive already. Okay? So this is assumed to be positive already, or to already have a positive operator. We use the negative operator. We can also do this, no? So the output should be 2. It's just to prove that the negative sign is actually an operator. So it negates this. So basically, this negative sign inside the parenthesis negates the value of 2, or negates the sign of 2 rather, making it negative 2. Then this negative sign outside the parenthesis negates the value of negative 2 to make it positive again. Okay? So basically, that's the unary positive and the unary negative operators. They are very straightforward. Okay? The next operators are the reference operator, also known as the address of operator, also known as the direction operator. Okay? So basically, it's actually very straightforward. So let's say we have a variable called int num, or rather num, then let's say the value is 1. So let's print out. So basically, okay, I'm telling you that this symbol here, the ampersand symbol, is the address of operator. I'll just call it the reference operator rather, okay? So, and num. So, what do you expect to be returned? Well, from the name itself, the reference operator or the address of operator, it will return the address of the variable. Wait, no, I forgot to close. No, I forgot to close the previous ones. Okay, I'm very sorry. But there you have it. So basically, 0x6 FFE46 FF4 FFE4C rather is what? That is the address of the variable num. Okay? So basically, you have uses for this. There are lots of uses for this, but if you think normally, there aren't really much, no? Now, the next operator, okay, again, I'll just repeat, because I myself, I don't think I have explained the address of operator really much. Basically, the address of operator is also a unary operator. It only operates on one operand, which is the variable name or the variable. It returns the address of the variable, which is why it's called the address of operator or the reference operator. Okay? Now, the next operator is called the dereference operator. Okay, also called the okay. It's also called the indirection operator. Okay, the indirection operator or the what do you call this again? The dereference operator is basically it returns the value of the address. That's why it's the reference operator. It's basically the complement of this address of operator. Okay? So, for example, let's try. I don't think I have discussed this yet. I don't think I have discussed pointers yet. But let's just say we have int num equals 1 again. And then let's just also say we have a pointer. We have an integer pointer called the ref, or it's rather ptr for pointer. So what is it equal to? So let's just say it's equal to the address of num. Now, what we want to do is basically this here. Okay, is it highlighted? Okay, that is the reference operator. Now, we're going to use it on PTR. Okay? So, what would be returned? What would be the output? The output should be 1. And otherwise, I did something wrong. Okay? So, there. The output is 1. That is because, so basically, PTR here, PTR is, the value of PTR is the address of the variable num. Now, when we use the dereference operator here, the asterisk symbol, since PTR is equal to the end num, the ampersand num, basically, this will dereference the address, or this will take the value of the variable with this address and num or PTR, okay? So, medyo magulo yata yun, pero magulo talaga. I don't know how to make it more simple. Basically, the dereference operator tells you the value of the variable placed in this address PTR. Since PTR is equal to the address of num. So, wait, let me check if this would work. No, I don't think it would. Compile and run. So, I guess it worked, no? So, basically, we just dereference. So, basically, okay, we have the variable num. Okay, we have the variable num with value 1. When we use the ampersand symbol, it basically returned the value of the address of this. Okay, here's another concept. So, I don't think I've said it. But ever since we started with the increment operators, by the way, the prefix increment, until now, the grouping of this is right to left. So, basically, this gets performed first. So, basically, end num. So, basically, it took the address first and then it would dereference it, okay? So, unlike normally, if, for example, we have 2 plus 5 times 6, or times 7, mali na pinindot ko. So, what would be the input of this? 2.5, 2 plus 5 minus 7, rather. So, it wouldn't matter what operation is done first, since they are of equal precedence, no? But normally, we would do 2 plus 5 first, and then we would do 5 minus 7. 2 plus 5 first, and then whatever the result of 2 plus 5, then we proceed to minus 7. But when it comes to these unary prefix operators, we do first what is on the rightmost side, okay? So basically, in this situation, the address of operator performs first, resulting in the address of the variable num, which we saw earlier. And then, the reference operator dereference the address, giving us the value of num, since it dereferenced this ampersand symbol. Okay, basically, I'm panicking here, I guess. I think so. So basically, the reference operator, the asterisk symbol, and the reference operator, the ampersand symbol, complements each other, meaning they will cancel out each other, okay? So basically, see out insertion operator, asterisk symbol, ampersand symbol num is equivalent to basically just that. So, this is also why it's called the indirection operator and the direction operator, no? Okay. I had a really hard time trying to explain that. Okay, now let's proceed to the next operators. This would be much simpler to explain, since this is just, yeah, never mind. Okay, the size of operator, I think I already used this earlier. So basically, the size of operator is also a unary prefix performing only on one operand. So let's say we have integer a. The value is not required, because the size of operator focuses on what data type A is. And then, it would return the size of operator performing on a variable would return how many bytes it can handle, or how many bytes can be stored. So in this case, the integer, since A is an integer, then based on the function of the size of operator, we can conclude that integers in this version of C or C++ has a storage of 4 bytes, equivalent also to 32 bits. So basically, that's the size of operator. Then what else? What's the next operator? Basically, the next operator is the casting operator. So let's say we have a floating point value. Float num equals of floating point, meaning it has a decimal point, it has a decimal value. Let's say 2.5. Float num equals 2.5. If we basically try to output num, then obviously the output would be 2.5, no? There, 2.5. The casting operator, which is basically in the syntax of this is basically data type, then open close parenthesis, variable name. So basically that is the syntax of the casting operator. So from this, we can try converting. Basically, casting operator is a conversion operator, no? It will convert a variable of a certain data type to another data type. So for example, we can do int num here. If we compile and run this, then the num, which is 2.5, or which was 2.5, was, because now it's 2, okay? Since previously it was a floating point value, then it can house decimal values or numbers beneath the past the decimal point, no? So float num equals 2.5. The value of num is 2.5. But the moment that we converted num, which was of the data type float, to the data type int or integer, then the output would be 2. Okay? As you can see, it was not rounded off. It was rounded down. So that happens. If we convert it, just like in C, if we use %d for a for a floating point value, or for a float, then the output would be rounded down, not rounded off. Okay, so that's just a concept to take note of. Wala na akong boses. Okay, what's the next? So basically, that's the that's the casting operator. Okay, the next set of operators are much simpler. So basically, is this the next set of operators are the arithmetic operators. Okay, so basically MDAS. Remember MDAS. MDAS or MDMAS. MDMAS rather. MDMAS. So what does MDMAS stand for? So MDMAS stands for multiplication, division, modulo, addition, subtraction. Basically, it's just that, no? So I will just try showing you examples performing these operations using the operators. Also to show what or how the operator symbols look like. Okay. For example, 2 plus 5. Obviously, the output should be 7. If the output is not 7, I don't know what's wrong. See out 2 plus 5, that should be 7. Okay, right? See out 2 minus 5. The output should be 3. Right? right? Negative 3 rather, sorry. And then if we use the multiplication operator, the asterisk symbol, we would get 10. Okay? If we use the division operator, oh wait, let's not do that. Let's do 5 over 2 instead. 5 over 2. What would be the output? As you can see, the output is an integer. Why is that? Well, it's because we performed with integers. We perform the operation with the integers. But for example, if we do this, then the output will be 2.5. That's because we perform the operation with floating point values. Okay? It's basically very straightforward. It doesn't make sense anymore. So, minimum of one floating point value, at least one, no, is required. So, as you can see, even though I converted 2 back to an integer, the output still is 2.5. Okay? The next one is the modulo operator, which is, for example, 5%. The symbol for the modulo operator is the percent symbol. So, the modulo operator would return the remainder of the division operation performed between the dividend 5 and the divisor 2. Okay. So 5 divided by 2 is 2, remainder 1. 2 modulo 2 mod 2 2 rather with the remainder of 1. So that's that. So the order of precedence for this is basically like MDAS, multiplication is equal to division is equal to modulo. Then we have addition is equal to subtraction. So it's that simple. Okay? Now what's next? We have performed the arithmetic operators. The next one is the bitwise shift operators. The bitwise shift operators. These are actually very straightforward as well and won't get you many errors. For example, let's say we have int num equals 1. Or let's just make it int num equals 6 rather. Int num equals 6. Now the symbol for the bitwise shift operator. So there are two bitwise shift operators, okay? So first is, yeah, let's just enter our expressions inside what do you call this? Inside parentheses, so that the operators wouldn't mix up with each other. And by the operators, I meant the insertion operators and the bitwise shift operators. And you will see why I think they will mix up, okay? Even though I don't think they will. So it's because the symbol for the bitwise shift operators are exactly the same as the symbols for the insertion operators and the extraction operators. So we have two types of bitwise shift operators. The bitwise left operator, the bitwise left shift operator, and the bitwise right shift operator. So basically, for example, uh, the bitwise shift operator is also unary, I think. I mean, not I think. I mean, I'm sure of it. Rather, num equals. Wait, why am I suddenly not sure of the syntax? Let me just do that. If it doesn't work, then I'll just, I don't know, primary expression. And now, execute, compile, and run. Primary expression before. Wait. How do you, tawag dito? Bitwise shift. Sorry, I forgot to put how many shifts. Oh, yeah, I always forget. So, for example, so basically, the syntax for this is, the syntax for using bitwise shift operators, basically var name, and then the bitwise shift to the right symbol, or the bitwise shift to the left symbol, or vice versa rather. Then number of shifts. So bitwise meaning we're talking on the binary level. So for your information, the binary for 6 is 00. Let's just make it 8-bit. So to make it more simple, even though integers have 32 bits, we wouldn't need the other bits though. So there. Let's just say we want to shift them to the right and to the left by 1. So what would be the outputs? Wait, I forgot put this. Okay, execute, compile. No. Execute, compile, and run. So, as you can see, for the first one, the output is 12. Okay, why is that? Since this is the bitwise shift left operator, okay, the, tawag dito, the insertion operator equivalent is called the bitwise left shift operator. Okay, so bitwise left shift operator. Bit left shift. So basically, what happened is from 0000110, this became 001100. So basically, the ones were shifted to the right, to the left rather. And so are the zeros, no? It's as simple as that. So what is the value of 1100? So if you make a place value table, that would be equivalent to 848400. So 8 plus 4 is 12, no? So tama. Then for the second one is bit right shift. So from 000110, this became 0000010. So what is the value for that? Ay, 0011 rather, 11. So 2 plus 1, if we make a place value table, that would equate to 0021, which is 2 plus 1 equals 3. So basically, I don't think if those explanations were enough, but basically that's that. The location of the binary numbers were shifted either to the left or to the right based on the number of shifts you specified. So for example, if let's say we want to shift the number bitwise to the left by 2 times, that's equivalent to to saying so what is the output? 24. So as you can see, if you've noticed the pattern here, so basically bitwise left shift is just saying, so for example, we have the decimal value is 6. This is just multiplied to 2 raised to the number of shifts. Okay? It's equivalent to that. Although, for what do you call this again? For bitwise right shift, it's actually equivalent also to 6 divided by 2 raised to the number of shifts. But this is much more complicated. Not much more, but a bit more complicated because of how when we do division operations, it's possible that we would reach the point where the number is no longer divisible by 2. Okay? Since the only numbers completely divisible by 2 until it reaches exactly 1 are the powers of 2 itself. No? Like 2, 4, 8, 16, 32, 64, 128, and so on and so forth. So, for example, we want to shift 12 2 times to the right. That would give us 3. since 12, then 6, then 3. But if we want to shift 3, if we want to shift 3 by 1, obviously this would give us 1, no? Let's try. Let's just make it 2. Pile and run. And then this will give 24 and 1. Why 1? No? It's because 0, 0, 0, 0, 0, 1, 0, 1, 1, 0. When we shift it 2 times to the right, so 0, 0, 0, 0, 0, 0. So this right here gets placed in the last digit. What happens to this? No, it gets discarded basically. That's the reason why the answer now is just 1, okay? It's a bit straightforward, not a bit too much, but yeah, I guess so. Now the next one is the relational operators. Okay, these are much simpler also. Basically, the relational operators are just the relational operators when we use for comparison of numbers. So basically, for example, uh, int a equals let's say 2 less than 1. Is 2 less than 1? Is 2 less than 1? Yes or no? The answer is 0. 0 0 is equivalent to false and 1 is equivalent to true. Or 0 equates to false and 1 equates to true. Okay, it's that simple. So that's the use of relational operators. We also have the first of all, this is the less than operator. We have the greater than operator. The greater than operator. So for example, that of course it would return 1 since it's true. If we do 2 here, it would return false since that is not true. And sometimes we don't want that. That's why we also have the greater than or equal to operator. Execute, compile, and run. So basically, the greater than or equal to operator checks if operand 1 is greater than operand 2. Or if operand 1 is equal to operand 2. If either is satisfied, then one would be returned. So it doesn't matter whether only one is true because that would not be possible. A number cannot be greater than to another number if it is equal to itself, and vice versa. So then that's the less than or equal to operator. Very straightforward. Okay. They're of equal order of precedences, the 4 of them. The next one is the equality operator. Equality operators, these are actually also comparison operators. Basically, the relational operators and the equality operators together form the relational operators or the comparison operators. Can be called either. So basically, you may remember this, the not symbol, the logical not symbol. If this is mixed together with an equal symbol, this is the assignment symbol, but sure. So basically, this would become the not equal to. So is 2 not equal to 2? 2 is not equal to 2. Is that true or false? That is false. That is why the output is 0. Now, if you want to see if two numbers are equal to each other, we would use the equal symbol or the equality operator. Okay, or the equal to operator. Since this is not the equal to operator, this is the assignment operator, no? So, okay. Okay, we're done with the equality operators. The next is the bitwise and operator. The bitwise and operator. So, okay. Let's just skip this. So, for example, we have 110. Then the symbol for the bitwise and operator is a single ampersand symbol, just like the reference operator, or the reference operator rather. So let's just say we have I1, 110. I meant to write 6. Wait. I just wrote the binary value for that. 6 and then 5. So, so basically, the AND operator in itself, I don't care if it's bitwise or logical. Basically, it checks if the two operands are, ano, wait, checks if the two operands, no, rather. For bitwise, it checks if the two numbers, no, sorry. The logical AND operator checks if the two expressions or the two operands are both true. If they are both true, then it would output 1. If one of it is false, or if they are both false, then the output would be 0. Okay. For bitwise operator, on the other hand, for bitwise AND rather, so basically it checks the binary value for this. So for 6 it's 110, for 5 it's 101. And then just like the logical AND, so if for example the first one, so basically we can see they have three binary place values. Okay? They have three binary place values, the 4, the 2, the 1. So as you can see, the first binary place value for 6 and for 5, they are both equal to 1, meaning they are both present. And so the output would be the output would be 4. The output should be 4 because that's the only part of them. That's the only part of their binary place values that are both present on each other. That are present on each other. So, for example, we have 000, 1010, and we also have 111, 1111. So, let's just put it. The output for this would obviously be none other than 000, even though the second number has all these ones, no? But the first number doesn't have it. So basically, it's still 0. But for the place value 8, no? They both have 1, so that's 1. Okay, and then 0. And then 0, 1, 0. So basically, it's the intersection, okay? In terms of sets, or this is the set intersection. Okay? Where do the place values intersect? When when the binary place values of two numbers are both equal to 1, no? Then it would return 1 for the new value or for the AND operator performed. Now, the next is the bitwise OR operator. The bitwise OR operator is similar to the set union. So obviously the what do you call this? The value of this would be 7. So why is it 7? Because 110, 101. So it doesn't matter if only one of them has 1. As long as one of them has 1, then the resulting value of that place value would be 1 also. So 110, 101. So 1 where's we have 1, then 1 and 0, so that's 1. 0 and 1, so that's 1. 111 is equal to 7. Okay? That's why the output is 111. The next operator that we're going to discuss is basically the logical AND operator. I already discussed that before a while ago, but sure, I'll just make an example for it. The symbol for the logical AND operator is double ampersands. So, for example, 6 greater than 2. So 6 is greater than 2, is it true or false? True. Is 5 less than 12? It's true. So then the output should be 1. Because this is a set intersection. The result would only be 1 if both expressions are true. But if, for example, let's just make this greater than symbol is 5 greater than 12, no, it's not. The output should be 0. Okay? Now, the OR operator, the logical OR operator, is basically the double vertical line symbols or the parallel line symbols. So, as you can see, the output is 1. Why? Because 6 is greater than 2. If the first operand is 2, then it wouldn't have to check the second operand. Because this is already true. Right? No. Okay, so, right. Now, what is the next operator that we're going to discuss? The next operators or the next set of operators are the assignment operators. This is the assignment operator. The basic assignment operator, the equal sign, we've been using that for ages. So I don't think I have to discuss that further. Basically, the function of it is assigning a value to a variable. Okay? Now, what are the other assignment operators? The other assignment operators, the compound assignment operators. So basically, let's say int a equals 1. Okay, so we have a, first of all, is plus equal to 1. That is the first compound assignment operator, the plus equal to. So basically, what this does, so basically, a plus equals to 1 is equivalent to a equals a plus 1. Okay. So from that pattern, we can say that a times equals to 1 is equivalent to saying a equals a times 1. A minus equals to 1. Wait, tama? A minus equals to 1 is equivalent to saying that a is equal to a minus 1. Okay? And also, saying that a division equals to 1 is the same as saying that a is equal to a over 1. So basically, it's the same for all compound assignment operators. So I'm not going to explain that further because the concept is just the same. Now I'm just going to write for you and tell you the different compound assignment operators. So you've already seen the plus equal to. There's also the minus equal, the multiplication equal to, the division equal to, the modulo equal to, there's also that. So basically, modulo equal to, that's equivalent to ano? To, for example, x, or rather a percent, where is percent? Percent equal to 1. That's equivalent to a equals a percent 1. Or rem of a over 1. Okay? So it's basically just that. Very simple. So the next one after the modulo equal to, we also have the bitwise shift equal to, sorry, both of them. We also have the bitwise and equal to, the bitwise or equal to. We also have both of them, the ano operator to. Okay, nakalimutan ko na rin. this is the XOR. I forgot to discuss the XOR operator, the bitwise XOR operator. So basically, the bitwise X operator is basically just the XOR operator, but it will only it will only return the value of 1 if only one if only one of the two numbers has a 1 on that. So for example, if binary, these are binary representations na, I want so for example 6 and 5, 6 and 5. Sorry, what would be the output of this? So 6 x or 5. So written in binary, that's 110 and then 101. So the output would be 011. Why? Because 1 1 and 1, both of them are 1, so that's not possible. Because this is XOR, exclusive OR, it will only result to 1 if only one of them has 1. Okay? So 1 and 0, 1. Okay? 0 and 1. Okay? 1. Okay? 1, 1, 0, 1, 1 is 3. Okay? So that's that. Okay? That's the recap for the XOR operator. So we have XOR equal to, and we also have the not equal to. The bitwise not equal to. Bitwise not equal to. Okay? So that covers it for the assignment operators. And how long oh, I have been talking for 1 hour already. Wow. No wonder my throat is very itchy. Okay, the next is, okay, don't worry. These are the last two operators, okay? We have anong tawag dito sa operator na to? The conditional operator. So basically, the conditional operator is just like an if-else statement, no? For example, we have, let's just remove this. We can remove that now. For example, see out. Let's just make it up inside the parentheses so that it wouldn't be confusing for both the user and the compiler. So the syntax for this is expression, then a question mark, then what to do if true, and what and then rather return if true, then a colon, then a return if false. So first of all, for example, expression 2 is less than 5. Then we have the question mark. So, for example, the return would be true. Then colon, false. Basically that. What would be the output? The output is true. Why? Because 2 is less than 5. So basically, this is an if-else statement, no? So if 2 is less than 5, then return this. If not, return this. Okay? That's basically the conditional operator. The next operator is the sequencing operator or the comma operator. So, an example of this would be, let's say, you have two variables, int a equals 4, b equals 5. Now, also, let's say we have now, C out, C. Let's say C is equal to, okay. Let's say we have that. Let's say B is equal to 5. B is equal to 6. Then A plus B. 1. What will be the output? I use too many commas. The output, what will be the output? Execute, compile, and run. The output should be 1. Okay, correct. The output is 1. This is because basically what the comma operator does is basically it performs this expression and then it discards this if there is another expression. So basically A plus B. C is equal to A plus B now. C must be A plus B. A plus B, what is A plus B? 4 plus 6. So C must be 10. But then I have another comma. Then I'm telling this that C is equal to 1. So basically C is equal to 1. Because it discards the expressions before the latest comma. If we remove that 1, oh no. I discussed too many things and then I would get to see that, hindi ko pala na-close yung ibang consoles. Ay nako. Hindi nakita kung ano yung output. Okay, so you see the output there is 10. No? So you can see that the output is 10. Okay? Yeah, so I guess that's all of the operators that we have to discuss. Bro, yung isang oras yun. Ganun. Okay, thank you for watching. See you in the part 5 of the series, Programming from the Perspective of the High School.